Muy bien, muchas gracias.
Thank you very much. Now we're going to pass the word to Oscar Tomas Vegas. Important exports of data EPANET using the program model V version 2.1. So importing and exporting data from EPANET to the gvSIG environment using the module of programming module version 2.1.
Bueno, sí.
Good afternoon to you all, and say thank you very much to the gvSIG Association to allow me to participate in these conferences. I'd also like to say thanks to the teachers I had giving me an introduction to scripting. I learned quite a lot about scripting, I must admit, and I would like to continue with development in this area. Right. The topic we're going to take a look at tonight, what I'm going to explain is two routines, which are importing and exporting models of data models from EPANET to the gvSIG environment. At present, I'm doing a doctorate at the moment, PhD, in the University Polytechnic here in Valencia, and I'm within the Regis group, so it means I'm taking advantage of knowledge, of the teacher's knowledge and the lecturer's knowledge and of my colleagues' knowledge, the people who are in the group with me. Right, so I'm going to point out what we're going to take a look at here, the breakdown, to take a look at a bit of background, what has happened so far, as far as tools are concerned, for interacting EPANET with gvSIG. We're going to take a look at the data model which has been proposed, and we'll also have the scripts. We're able to take a look at these two routines and their application in 7 cases, real cases, to be able to contrast what we're talking about, and future lines of work also we will take a look at. So take a look at the background now. I've divided it into 2 parts. The first of these I'm going to look at plugins which have been used from gvSIG, and others are external tools within the plugins we've developed so far. We've got INEP-COM and v2.1, which are using an environment, a gvSIG environment. And the first of them, the INEP-COM, was developed by a consulting company, and it was used for the environment 1.11 of gvSIG. At present, this extension cannot be used in these versions, in the most up-to-date versions, such as the 2.2 or the 2.1 version. And basically, the task that these plugins do is to export data. We already have this. We've got geometric and alphanumeric data, and it transfers them to EPASwing and EPANET. Basically, these plugins were developed to testing, but we also made some codes to adapt it and leave an ENP file. This file of EPANET basically leaves geometric data from the network. It doesn't pass the alphanumeric data. The next plugin, which is called v2.1, there was a cooperation project carried out between universities, between 2 Spanish universities and a university from Honduras. And basically, what they did was to plan and design network systems, supply network systems for water supply in rural areas and in the south of Honduras. And we take a look at the external tools. We've got 3 tools. We've got Zonums, which is a website, a web page, where there's somebody developing as a hobby different tools without using any SIG, GIS, simply a programming environment, and in certain cases using the dynamic library of EPANET. And the ones that are related to the work which has been done are 2 tools, the EPADOS.GIS, EPADOS.GIS. Their names are quite intuitive, which is to transfer the information from the EPANET file to the shape file. In the first of these, it's not operative, the EPAD office. It cannot be used. And in this following, they will be able to pass from shape to Oh, I think I've made a mistake here. It's SHP2 EPA. It should say EPA, not GIS. And in INP tools, which is from Mackie from 2014, we've developed a tool which basically has been evolving from operative systems from XP up to Vista, Windows Vista, and after that there was a change in the way of with Windows 7. And basically it's a menu. There's a floating menu there which functions, which only works if when you do a right click on an ENP file, a menu will come out and you will have a set of tools available. Within these you will find the ENP2, CHP, and SHP2 INP, which is import export INP files. And from the group, at the beginning of 2015, there was development of I developed a tool to make this much more comprehensive and complete, because there were many things left on the road. So there was programmed using a Visual 6 language, and it didn't use the functions of EPANET to be able to load the information because it has functions. Simply, it read the code which is in the text file, and this has been dumped into the data model, EPANET SIG, and we took a look at the sessions yesterday. There was explanation about what the EPANET software is, and the bit of to summarise a bit, the developers and Rossmann, who worked in the EPA and the Environmental Protection Agency in the United States, and they did hydraulic analysis of the quality of water. It's free software. The code is also open. It can be downloaded, and you can do things with it. It's also got a toolbox, which is a library, dynamic library, where a developer can customize the calculation model. We have in this panel data model, we have a classification here of how rating the different sections which are used, the key sections within the file, the ENP file. In the box here in red, we can see the 6 visible elements, which we can see from the panel interface, and the rest are the sections which are useful but which aren't visible. So it's practically, this is to do the setup of the model, to configure it. Here we have the text file, which can be opened in a block of WordPad, and we can see different sections here. This was just to show you the sections, how they are, and the fields we can see. In the junction section, we've got ID, the elevation, the demand, and the modulation curve. So with the data model, the GIS data model, which has been proposed by the group, to be able to dump this information, which is in the ENP file on the panel, in the SIG. The SACE first, which are in the top area here, in the visible area, where you can be seen the interface. The second line of the 6 are also visible, but they're used basically to do development work. In the case of sectorizing a network, for example, of a supply network, and to identify where the cut-off valves are, for example, limits, and this would help us to know the algorithms and to be able to carry out this sectorization and to simplify networks, basically. And in the final part of it, we have tables here where all the information is stored for the configuration for the network setup, control laws, etc., legislation, and the calculation units which are going to be used. Right, we look at the script for importing and exporting. The EPANET file is being developed. Here we've got two diagrams, flow diagrams here. Flow to see how work has been carried out in these two routines. For importing in EPANET, what we have is to select a file. We have to read this file with Python language and to make a temporal structure. After this, we would create the files, save file, and the tables, DVFs, with the gvSIG, and then we would finally write all this information which is in the temporal structure in these files. And finally, we would show in the doc version in the TOC we show all the visible components, and the non-visible ones are shown in a grouped fashion. And in the flow diagram for exporting the file exportation, we choose the directory where these files are. And after this, we make a type of identification that these are the correct files, and to see if the fields match also. If it doesn't match up, then nothing else will be done. There will be a message that comes up saying one cannot proceed because the table has been modified or eliminated. If they do coincide or match up, the next thing is to read the information, the geometric and alphanumeric information, with the tools of the gvSIG library, and then finally we would write an NEP file which we can actually read in these tables. So this is basically this is the figure I want to show, the illustration which was carried out with these two scripts for import and export, where we can see we've loaded an ENP file and we've shown the TOC, the classification. It's been classified by a layer of nodes and a layer of lines, keeping up the same philosophy, working philosophy. Some work, for example, with pumps in one certain point. Right. How can we take a look or contrast or compare or test these scripts? Well, it's been applied to 7 networks. 2 of them are from Spain. The network from Haifa is from Israel, and another one we have from Brazil. We have one from here, Pedreguer Teruel, from Gandia, and one from Valencia. These are here in Spain. The classification is done. Pedreguer has got almost 900 elements, and Belicosa nearly reaches 20,000. In the graph we see here at the bottom, these are the times were used up in seconds by these 2 routines. On the left we see for importing, and I compare it with the scilib library, which is shapelib library, which can be used and programmed in different programming environments, and also the gvSIG library. As we can see here, the Pedreguer network, which is the smallest, and Belicosa, which is the biggest, we can see here the times which are used up between the 2 using the 2 libraries. The advantage of using gvSIG is that we can have everything put in the TOC with the correct symbol, with the symbology that we want. When we look at the export side, it's extremely fast. It doesn't take even a second for any of the 12 libraries we're looking at here. This means that we can continue advancing with all the development that we want to carry out. Right now, future work. We want to create an extension or a plugin. I've actually called it a name here, which integrates all functionalities that EPANET has, and to incorporate the 2 scripts which have been previously developed. Then I'd also like to incorporate with open source databases like PostgreSQL and PostGIS and SQLite, as we already have sectorization and simplification tools. We just want to incorporate these within these future development. And finally, what we want to do is to And the good thing about is that we want to adapt the results which come from the hydraulic analysis to the GVs, to the GIS. And that's all I have to say. Thank you very much for your attention.